Stange Belisco here. This circuit diagram or block diagram relates to my video that I made a couple of days ago in regards to listening to ultrasound. Basically what you can do is take a very low frequency converter, which is what this block diagram actually shows, and replace the antenna with an ultrasonic transducer. But first let's just describe how the circuit itself works. The very low frequency and low frequency signals, say around 80 to 90 or maybe even 100 kilohertz or so, enter this mixer and mix with the signal from a local oscillator. Just for argument's sake, or for reference, or for an example, let's say that this oscillator has a frequency of 3.600 megahertz, which happens to lie in the 80 meter amateur radio band, and this mixer serves as an amplitude modulator at these low frequencies, so that what you get is a carrier at 3.600 megahertz with sidebands going on either direction above and below it, and you can tune through those sidebands with a CW, that's Morse code ham radio receiver or shortwave radio receiver. This receiver must have a product detector so that it will receive carrier waves like CW and radio teletype and things like that. You set this CW receiver to 3.600 megahertz and you're listening to a frequency of 0 or DC, and as you tune away either side of 3.600 megahertz, you will tune through very low frequency signals. For example, WWVL, which used to transmit on 20 kilohertz, would appear at 3.620 megahertz and also at 3.580 megahertz. You can take your pick. I prefer to tune up because it's just easier to understand the frequency conversions that way. And I've done this. I've actually used a Drake T4X transmitter as the mixer. I went into that in a couple, 3 other videos that I've done in relating to ham radio. But here, this can just be an ordinary amplitude modulator or mixer, and it'll work great for receiving very low frequency. Well, very low frequency radio at a frequency of, say, just above the human hearing range, 20 kilohertz on up to maybe 100 kilohertz or so. When that energy comes in this antenna, the radio frequency, very low frequency energy, the currents in this feed line are exactly the same as they would be if we replaced this antenna with an ultrasonic transducer, exducer. Now that might be something as simple as a hi-fi tweeter, but it'd have to be a good one, or a piezoelectric transducer, something to pick up ultrasonic waves and deliver then these frequencies, which are the very same currents that you would see with VLF and LF radio, to this mixer. And then you use the CW receiver and tune in exactly the same way, but instead of receiving VLF radio signals, you are tuning through ultrasonic signals. So for example, a 20 kilohertz ultrasonic signal bordering on the range of human hearing would appear at these frequencies. A 100 kilohertz ultrasonic signal would appear at 3.700 or 3.500 megahertz. And so it goes. It's the exact same circuit. You might want to add an amplifier here to increase the sensitivity between this transducer and the mixer or modulator. And then these, of course, are not VLF and LF radio signals, but instead ultrasound. Now that's my idea. I've never actually tried this circuit. I have communicated on high frequency sound waves, say about 12 kilohertz or so, maybe down to 4 or 5 kilohertz, acoustic communication using a tweeter like this. It works, but remember, the speed of sound is much slower than the speed of light, so your communications range is limited. And I talked about the atmospheric warbling or distortion that can occur because of turbulence in the air. So you might replace this transducer with add to this transducer a big ear, a parabolic dish, and then aim it at various insects and other little critters and see what kinds of sounds they make in the range above human hearing. You wouldn't hear the sounds as the other insects would hear them exactly, but you would be able to detect them just as you would detect VLF and LF radio signals using this receiver. So that's my idea for an ultrasound converter, which someone indicated some interest in listening to the sounds that insects might make, and I think a lot of those sounds are in fact ultrasound, as you might also hear other unexpected noises at these frequencies. There's only one way to find out. Stan Gibilisco signing off. Until next time, so long.